Hi, this is Vinod. I'm going to talk to you about one of the basic fundamental data structures that you would come across, which is namely the stack, wherein it's all explains the concept of LIFO, last in, first out. Whatever goes in first comes out last. So it's one of the very useful, commonly used data structure to structure and arrange your data. It's largely used in system architectures, system tables, when you run your programs, all the variables that you declare, the memory that is stored internally by all the programs or the applications internally uses stack to store all your data. So that's one of the very common data structure, and almost typically every language, programming language like Java, Python today has their own implementations of stack, which pretty much gives you the same functionality, just it's in its own flavors of the language. So before we go about what exactly it is in specific to a language, let's talk. See, I would like to show you a demonstration of what a stack is with a simple tool or toy, I would say. Let's say I use this toy. Let's say this is one kind of tower of in equivalent of Tower of Hanoi. Let's say I put this multiple various size of rings. Let's say I put in the black ring first, okay, and then I put in, let's say, this is, imagine, visualize this as something like a container, right, wherein it's just a box where you put things inside a box, right? So what typically lets you do it is you can take only whatever is in the top of the box, and only then you can reach whatever is at the bottom of the box. So here, let's say I have put a black ring, and then I put a red ring on top of it, and then let's say I put on top of that red ring a green ring. Okay, so now this is now kind of like a stack where all the rings are stacked one on top of the other. I probably That's where the name has arrived from. And now the basic functionality is, you can, if this is my data structure, a data structure is nothing but the way you're structuring the data so that you can access it in a very convenient and a very efficient way. And now if this is my data structure, and the way, if I have to access the data, I have to access the data only in the same way, the way in which I have put it, while it's just in the reverse, right? Suppose if this is the elements that are there in my stack, I can take only whatever is in the top of the stack. So typically, taking an element from the top of the stack is what they popularly call it as pop. So you're typically popping the element from the top of the stack. So I have popped out the green one here. Okay. So now, if I'm trying to put it back, and what it actually means is, putting an element into the stack is called as pushing it inside the stack, and taking an element out of the stack is called as popping out of the stack. So now the order in which I can pop out elements is whatever is in the first top of the stack. So if I want to pop black out of the stack, I cannot do it until I pop all the elements that are on top of black ring. So here in this example, if I have to pop the black ring out, I have to pop the red one first out, only then it allows me to pop the black one. In the interim, after popping out the red one, let's say I pop in something other, let's say I pop in again a green one, then green one becomes the top of the stack. So whatever is on the top, what we call them as top of the stack, and putting an element into the stack is popularly defined as push operation, and taking an element out of the stack is what they popularly call as pop. So these are the fundamental operations that you do, and typically when you pop all the elements out of the stack, we generally call it as the stack as empty. There's no more elements in the stack. So you can push elements, as long as typically in programming applications, the size of the stack is limited. You cannot assume as an unlimited stack. I can put, let's say, only as many, say 10 or whatever, as many size of the stack that allows. I cannot go beyond this size. And one, I can pop out all the elements from the stack as long as the stack is not empty. So once the stack is empty, I cannot pop anything more. So in this example, I push a black, recollect, I push a black element into the stack, and then let's say I push another now red one into the stack, and now let's say I push another green element into the stack, and then forward. Now these are followed by 3 push, and now pop the green one out, pop the red one out, and pop the black one out. And now my stack is empty. I hope I could explain the fundamentals of a stack and what the basic operations allowed on a stack. Thank you.